This technique is recrystallization. What we have here is some compound that's a bunch of white crystals, and what we need to do is get it dissolved in some solvent, the minimum amount of solvent possible, and then let it cool back down and let the crystals come back out of solution. Since this compound's pure to begin with, it already has a nice crystal form, but if you're working on purifying a compound that is impure, frequently this process will actually change the shape of the crystals. The key here is to use a minimum possible amount of solvent. I have about a gram of compound in there right now, and if I were to add 1 full milliliter of solvent, that would almost certainly dissolve all of it in this case. So what I'm going to do is add a very, very small amount of ethanol. And as you can tell, it didn't dissolve anything, or it didn't dissolve much at room temperature. But even that tiny amount of solvent might do things as soon as I heat it up. So I'm putting the compound and the tiny amount of solvent that I added into a hot water bath. I'm using ethanol as the solvent, so it should start to boil fairly quickly. And what you'll see is that this compound will collapse and start to shrink down and start to dissolve. And I don't want to add too much solvent at a time, but if the amount of solvent that I've added is not enough, what I then do is add a little bit more. And then allow it to heat up again, try to stir it, and see where we stand. And we just continue this process until the compound actually ends up dissolved. You can see that the compound is now collapsing down into the solvent. And what may be difficult to see on camera is what I'm looking for is the actual start of bubbles forming in the solvent. If the solvent is boiling, then as much of this compound is dissolved as it's going to. If the compound is not dissolved and the solvent is boiling, then I need to add a little bit more. So I add a little bit more solvent, a little bit more ethanol. Not much. We continue this process until the compound is completely dissolved. Right now, you can still see compound on the bottom of this test tube, and so I keep heating it and I keep stirring it, and what I'm looking for is a clear and colorless solution. The only reason why I'm sure that this one is going to be colorless is because the solid was colorless to begin with. So there we have it. Now the stuff is dissolved. All I do is let this cool down slowly. So I will clamp it over here off to the side, and we'll just let that sit. As it comes to room temperature or perhaps colder, you may notice it start to come out of solution. And I can repeat this process with a number of other compounds. Here, I'm returning to the copper sulfate, and again, I'm reasonably confident that a large amount of water would get it to dissolve. So I add a small amount of water first, and see where I stand. The compound's just barely wet. It's not actually dissolving yet. So what I do is I heat this up, and I try to use a minimum amount of solvent to dissolve it, and we see where we stand. And again, what I'm looking for is the appearance of bubbles on the solvent, because once the solvent is bubbling, that means it's boiling. And if the solvent is boiling and compound is not yet dissolved, then I need more solvent. So you keep stirring, you keep watching, keep stirring, keep watching. See how there's compound up on the top of this? I need to make sure that all of the solid gets dissolved in order to recrystallize. So a little bit more water here, and we're almost there, but there is still solid remaining at the bottom. So we're just going to keep agitating, let it boil, add a little bit more water as needed until all the compound is dissolved. In this case, what we're going for is going to be a clear but blue solution. Because the solid was originally blue to begin with, I'm anticipating a blue solution. But whether the solid is present or not, you can tell by whether it's opaque or clear and transparent. As you can see, what's happening already to the previous compound is it's coming out of solution. Slowly that's becoming cloudy, and what's happening is that solid is coming out. This particular compound, since it was so concentrated, when all is said and done, it will look like a solid chunk. But that's not true for all recrystallizations. Now, all of the copper sulfate is apparently dissolved, and what we'll now do is let this cool down slowly and see what happens. And again, this is now solidified, but it doesn't have to solidify. And notice that it's not really a solid. What it is still a liquid with a fair amount of stuff in there. And notice all I have to do to get it to dissolve again is put it right back into the hot water, and sure enough, raise the temperature and the compound will go back into solution. If I raise the temperature enough, of course, it will all dissolve all the way again and go back completely into solution. Just like that. One last compound I'm going to show. This relatively pretty green compound. Again, don't want to add too much water to begin with. Basically want to get it slightly wet down in there before we start heating. Don't want to add too much solvent, otherwise you don't necessarily recover all of your compound when all is said and done. Then we heat it, and we wait to see what happens. The more you agitate this, the more likely it is to dissolve, and once it starts boiling, then you know that you need a little bit more solvent. Once you've added a sufficient amount of solvent and stirred vigorously enough, then all the compounds should dissolve. And again, if there's just trace amounts of solid left over, then what that means is you need a little bit more solvent, not much more. Cloudiness in the solution is a sign that the compound has not yet dissolved. So I'm looking for a totally clear solution. In this case, of course, we expect the solution to be green, but it needs to be clear when I'm done with this. Or at the very least, there needs to be no solid remaining. It's not totally transparent, but now there's no longer any chunks of solid remaining. I'm going to set that down over here. So, as you can see, once again, this compound has come back out of solution, and once again, though it appears to be a solid, it's still dissolved in a small amount of liquid. So what happens if I add way too much of the solvent? The problem can be that the stuff starts to dissolve at room temperature, which means that you won't necessarily get your compound back. If I can get this all dissolved at room temperature, then I may not be able to recover all of the solvent that's in there. So let me just add quite a bit more solvent than I needed to have in there and heat it up, and we'll see what happens to it. As I've shown you before, all of that solid that I had in there dissolved in less than 1 milliliter of solvent. So now that I've added 5 or 6 milliliters of solvent, it will definitely go into solution. It may or may not come back out of solution. And then there's some tricks we can play to try to make compounds come out of solution if they are being slow. We'll let this cool down now.
I let this sit for 1 hour.
Where we stand with the copper after a long time, and where we stand with the green complex. Again, slow recrystallization. And not surprisingly, add way too much solvent and the compound never comes back.
In order to show some other interesting features of recrystallization, I redissolved the 2 compounds that had come out of solution. In addition, I dissolved another compound so that you could see how it crystallizes.
Okay, we now have 4 test tubes lined up, and we're just going to let them sit in order to recrystallize. This is the too much solvent compound dissolved in ethanol, so we don't expect anything to happen with it. Obviously, here we have the copper sulfate, the green solution, and this is just a separate compound that should crystallize out over time. We're going to speed this footage up, and we're going to see what happens over time.
As not much is happening, even at 4x speed, I am now going to do stop motion with the actual visuals. You get the idea. Recrystallization is definitely a process that requires patience. For reference, that was about a half hour.
Sometimes, for the purposes of recrystallizing, it's best to let things grow very slowly, because then you end up with very large, pure crystals. However, if you have some crystals forming already, then agitating the solution will speed it up, the process of crystallization. There's a significant amount of crystals at the bottom here, but I'm going to let the rest of this happen a little bit slowly. If we look at this blue solution, we don't have any crystals forming yet. Not on the bottom, not anywhere else. And this particular colorless solution also doesn't have anything happening. In both cases, I think I have a bit too much of the solvent that dissolves them. So in both cases, what I could do is add a little bit of an anti-solvent. The whole idea behind recrystallization is that the crystals prefer to come out under certain conditions and prefer to stay dissolved in the solvent that you chose. You need to choose a solvent that dissolves them under one set of conditions, high temperature, and hopefully comes back out under other conditions. But if you get it wrong, then what you can do is add a solvent that the crystals don't like. So, we have this compound in ethanol to begin with. Presumably it doesn't like water, so let me add a drop or 2 of water, and you see something interesting happen. Little mixing lines as the water goes into the ethanol solution, and a hint of some crystals trying to form. And once you have a hint of crystals starting to form, then agitating the solution can frequently lead to good results. Again, I can choose to go quickly or I can choose to go slowly. I'm now going to add a large amount of the anti-solvent quickly. That didn't do it quite yet, so let me add a little bit more. And we're just about there. There's cloudiness now in this solution. Now you can see little bits of solid floating around in there. Agitate this aggressively. If it dissolves again, we can add a little bit more solvent, or we can cool this down. Put it on ice, everything will come out of solution. Add a little bit more of the anti-solvent, and again, stuff comes out of solution. Now that we have tiny little bits of solid in there, the rest of it goes pretty quickly. For something that was originally dissolved in water, then the anti-solvent would have to be something more organic. So, for example, I can add ethanol. Let's see what happens. The initial addition of ethanol will just hang out on top. Just a little bit of cloudiness right here. Agitate away. Not much appears to be changing right at the moment, so I'll add some more ethanol. Now you can see it has gone cloudy. Again, ethanol is sitting on top of the water largely, but as I mix these two, then what happens is I get the first hints that something is coming out of solution because I get all this blue solid forming. Cloudiness, when you're trying to recrystallize, is a sign that stuff is coming out of solution. And now we have a large amount of solid on the edges of this test tube, and we have a large amount of solid floating in there. If you care a great deal about the purity of your crystals, then this is actually a bad strategy to use. You want things to come out slowly as possible because then they make nice large crystals and everything works well. However, if you just want crystals to come out of solution, those are some of the tricks. Change the solvent, agitate. So what I'm trying to do here is there's crystals on the side of this test tube, and if I get some of those down into the solution, then crystallization will happen relatively rapidly. Agitate away, and again, what I'm looking for is cloudiness, because that really causes things to happen.
And that's recrystallization in a nutshell. Two that worked without tweaking, and two that required anti-solvents.